So we go to B. Find the real and imaginary parts of Z, given that Z is that, and also express Z in the form Z is equal to A plus BI, where A and B are real numbers. That's B1 and B2. So question 4, B1. We are given that Z is equal to 7 over 2i minus 3 over I power 14 plus 2i power 5 plus the root of negative 16. Now, under surds, A times B can be written as A, B, meaning that root negative 16 can be written as root negative 1 root 16. We also know that root negative 1 is the same as I. This is because I squared is equal to negative 1. So if you square root and the square root, you get that I is the square root of negative 1. So now this can be written as I, root of 16 is 4. So we're talking about 4i here. And then 2 to the power 5, you know, if I have a, b, n from exponential, it's the same as a, n, b, n. This means that 2i5 is the same as 2 power 5 and I power 5. 2 power 5 is 32. I power 5 is I squared, or I can say I power 5 is I power 4 plus 1. 5 is 4 plus 1. So that this becomes 32 I power 4 I. Meaning we have 32 I power 4 is I squared by I. So we get 32. I squared is negative 1. So negative 1 squared I. Negative 1 squared is 1. So we get 32 I. And then I14 is the same as I squared to the power 7. Because 2 times 7 is 14. But I squared is negative 1 power 7, giving us negative 1. Okay. And then 7 over 2i, this is 7 multiplied by 2i over, okay, to avoid complicating what you know, this is 7 conjugating multiplied by negative 2i by negative 2i. This will give us negative 14i over 2 by 2, we get negative 4. And I times I is I squared, which is negative 1. So this is negative 14i over positive 4. Divide by 2, you get negative 7 over 2i. The I is no longer in the denominator. So we come back here and say this is negative 7i over 2 minus 3 over negative 1 plus 32i plus 4i. So we put the i's together, negative 3 over negative 1, that is positive 3, plus 32 plus 4, we get 36i. So who else can get me?
You can get you, sir.
So Samuel, you can log out and log back. Must be your network. So 32 plus 4 is 36, and then minus 7i over 2. So you can do the fraction thing. So if you get 3 plus 2 down, 36 by 2, you get 72i minus 7i. That is 3 plus 72 minus 7. We get 65. 65 over 2i. So the question says, find the real and the imaginary part. So the real part of z is equal to 3, and the imaginary part of z is equal to 65 over 2. And then part 2, so this was part 1. Part 2, we are given z as 2 minus I over 1 plus 2I squared. This is the same as 2 minus I over, we can expand this. We can do the expansion of this. 1 plus 2I squared is the same as 1 plus 2I multiplied by 1 plus 2I. 1 times 1, you get 1. 1 times 2I, you get 2I. 2I times 1, 2I. 2 times 2, 4. I times I squared, which is negative 1. So we get negative 4. Negative 4 plus 1, we have negative 3 plus 4I. So now in the denominator here, we now have negative 3 plus 4I. And then we conjugate, we multiply this by negative 3 minus 4I multiplied by negative 3 minus 4I, which is equal to 2 times negative 3, we get negative 6. 2 times negative 4, we get negative 8I. Negative I times negative 3, we get positive 3I. And negative times negative, positive. I times I, negative 1. Negative 1 times 4, we get negative 4. Over negative 3 times negative 3, 9. Negative 3 times negative 4, positive 12I. And then minus 12I. And then I times I squared, which is negative 1. Negative 1 times negative, you get positive. Then 4 times 4, you get 16. This is the same as negative 10, or negative 6 minus 14, minus 5I over 9 plus 16, that is 25. So this is negative 10 over 25 minus 5 over 25I. Now, when you divide 5 into 10, you get 2. 5 into 25, you get 5. Minus 5 in itself, you get 1. 5 in 25, you get 5. So we have written Z as A plus IB or BI, where A and B are real numbers. So this was the question which I expected almost everyone to get to answer and get it correct. but the opposite is happening. When you are expanding, when you are squaring is different from conjugating. Now, some of you are doing this. 1 plus 2i squared is the same as 1 plus 2i, 1 minus 2i. Square means multiply that thing by itself, not its conjugate. So never do this. It's dangerous. Okay, we go to C. C, express the number.
So I'm kindly
1.2.
asking if you can. Okay, thank you.
Okay. So express 1.234 bar in the form P over Q, where P and Q are integers and Q is non-zero. So the first thing you do is you assume some letter X to be 1.234 bar. And then you move all the numbers that are not under the bar to the left side of the point. So how do you move? You multiply by a number with zeros equal to the number of the numbers which are not under the bar. So we have two numbers not under the bar, so we multiply by 100. 100x is equal to 123.4 bar. This equation is the one we call equation 1. For us to have equation 2, we now count how many numbers are under the bar. We only have one number. So we multiply equation 1 by 10. So that we have 100 times 10 is 1,000. And then here, we move this number 1 step to the left, and the others under the bar will remain. This is what we call equation 2. And then now we do equation 2 minus equation 1. So we have 1,000x minus 100x, which is equal to 1234.4 bar minus 123.4 bar. 1,000 minus 100, we get 900. 1234 minus 123, the bar minus bar will get 0. So 4 minus 3, we have 1. 3 minus 2, we have 1. 2 minus 1, we have 1. And then the one that is untouched. Then divide by 900. Divide by 900. So we get x is equal to 1111 over 900. You can simplify this further if there's a number that can go in both.
Oh, there's 9.
There's 9.
No, none. I tried 9.
Okay, good then. If you tried, then it's okay. But if you didn't try, just assume it. Then you're wrong.
I tried when I was writing, so.
Okay, yeah, there isn't any. Okay, then G.
Sir,
Hello.
asking if you can explain the first step.
So the first step you always want to have a form where you want the numbers to be in the form a point. Everything after the point should be under the bar. So if I have a case where I have A point B, C, and only C is under the bar, I have to move B to be with A. But this is only done by multiplying both sides by 10. Because I know that when I multiply decimal by 0, the decimal move one step to the right. But then the X on the left must be affected. And then you have A, B, point C bar. Now the numbers under the bar are sitting in this form. C, 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 C. You keep going. Now instead of us saying C, 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 we just say C bar. So when I multiply this C bar by 10, this C will move the other side. So I'll have A, B, C point, C, 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 C. When I get that, I just put it now. Because we still have that, we say we have A, B, C point, C bar. That's why the bar remains even if a number moves one step to the left for those that are under the bar. So the numbers that are not under the bar will guide you on which number you must use to multiply with here. If there are two numbers, you multiply by 100. If there are three, you multiply by 1000. Always. Okay, let's go to D. D, given that root 3 is irrational, given that this number cannot be written in the form A over B, that is to be rational. And then determine whether or not root 3 plus 2 is irrational. Determine whether or not root 3 plus 2 is irrational. So what you do is you assume that root 3 plus 2 can be written in this form, where B is non-zero, A and B are integers. You also demand that A and B do not have a common factor. Okay, but then in the nature of the equation, root 3 plus 2 is equal to A over B. We can take this number the other side. So we have root 3 is equal to A over B minus 2 over 1. But this is B common denominator, and then A minus 2B, giving us A minus 2B over B is equal to root 3. Now we said that the question is saying root 3 is rational. Root 3 cannot be written in the form A over B. But since A minus 2B is an integer, B is an integer, then A minus 2B over B is a rational number. But rational can never be equal to irrational. Hence, root 3 plus 2 is irrational. That's how you do the proof of this. And we call it a proof by contradiction. So you assume in contrary.
Sir,
Hello?
why was the splitting like that? On root 3 is equal to a over b minus 2 over 1.
Come again?
I'm saying, why was the splitting done like that? Did they say that, I mean, where did the 2 over 1 come from? Sorry.
No, whenever you have n number, you know the denominator is always 1. Even in the fraction.
No, sir. My question is, how did root 3 plus, is it that the 2 is included in the root?
What do you mean by in the root?
Like that, didn't they say that root 3 plus 2 is equal to a over b? Now,
Yes.
how did you split it like that?
Root 3 plus 2 is equal to a over b. If you have x plus 1 is equal to 7, and you want to find x, what do you do? You take one the other side, is it?
You take one over side.
So it will be 7 minus 1, so that x is what? 6. So if we have root 3 plus 2, we can decide to take 2 the other side. So we have root 3 is equal to a over b minus 2. But since 2 is a whole number, then we know that its denominator is 1. So we're solving for root 3 because we've been taught something about root 3. We've been taught that you cannot write it as a fraction of 2 things. So I want to see if it's not possible. If you find that it's possible, then we have a statement about the irrationality of root 3 plus 2. So that this ends question 4. Very good note. Okay. So we are supposed to start question 5. So log out and log back quickly and start question 5.